So what are the fluxes that you're talking about? What's the flux across the face of the control? Well, there are 6 faces, but I just illustrate what a flux is with just looking at the eastern face. You have the eastern face of your box, of your control volume. Yeah, let's say it again. It's a virtual volume, and this is a virtual face. Okay, we took a cube. Okay, and so here the area called A of this face is just the square of the side length. Okay, the drawing is not very good, but just imagine that it's sort of a square here, right? Okay, and then what a flux is, you have a property, a concentration just outside your control volume, and shown here is the situation in which a flow, a current, actually moves the property across the face into your control volume. Yeah. So if you now look at the product, the velocity component, U, times the concentration, just upstream from the face, n times the area of the face, this is what gives you the flux. The flux of a property into your control volume, or it can also be a flux away from your control volume. Okay? Just where the velocity component can be of the opposite direction. Okay, so if the flux is if the velocity component is reversed, then it would be the flux of the property that's inside your volume, your control volume, and the movement of that through the face to the outside. Okay, so if you now look at the units and you work out what is the unit of a flux. Okay, so we take the U as in meters per second. The concentration that we had of our property is in kilograms per cubic meter, and the area is square meter. And if we now look at all the units and just simplify this, it turns out to be kilograms per second, and this is exactly what we want to have. Okay, it is a change of the mass of your property in kilograms per second, per time unit. Okay, and you can see that the flux actually changes the amount of your property in the volume, in the control volume. What now matters is actually having all fluxes together. You know, you have 6 phases, and you could have fluxes that at value or at concentration, and some remove concentration, that all that matters in the end is the sum of the 6 fluxes that you have. Okay? All right, so this is if we're talking about control volumes and looking at the contribution that come from fluxes from all sides. Okay? And then in the ocean, if you think about the top phase of your control volume, indeed, that is the interaction with the atmosphere that you have, for example. Okay, or if you extend your control volume to the seafloor, then the seabed would be the bottom phase of your control volume. Okay, so there are many applications of such control volume.